Hello, everyone. Thank you all for coming to our second webinar on lithium-ion batteries in collaboration with Seascope France. My name is Kim Llorente. I'm the operations manager at the PYA, Professional Yachting Association based in Antibes. In our previous webinar, we discussed the importance of awareness of lithium-ion batteries and the development of the MCA guidance note MGN 681. Well, today we're going to delve into the challenges of navigating today's landscape and offer some solutions. I'll let our knowledgeable panelists introduce themselves quickly. So, Gerard, can you start, please?
Yeah, hello everyone. Yeah, my name is Gerard Pollock. I'm an ex-super yacht captain, port state control officer, and I do consulting and writing books and courses.
Thank you. Ollie.
So my name is Ollie Templeman. I'm a captain of a classic yacht, currently under conversion to full hybrid propulsion system, with the expectation of achieving a green notation. So I'm going to try and elaborate on our journey so far.
Excellent. Thank you so much, Ollie. And Ed.
Yeah, hello, Edward Henny here. I'm a flag state surveyor on behalf of the Cayman Islands Registry. I do some other identity service as well. Ex-Lloyd surveyor, ex-marine chief engineer, navigator, and a Master of Science, Maintenance and Safety Management, and 3 decades in the marine industry, and still learning.
Yes.
Oh, thank you, Ed. So we have some excellent panelists, and I would start with Ollie. Can you tell us a bit about your experience with the refit of your boat?
Absolutely. Well, I landed here 9 months ago. She's an old classic from '67, a British-built boat. I arrived shortly before the final commissioning of the hybrid control system was completed. And now we're at a stage where the lithium-ion propulsion batteries are now at the design stage or risk assessment stage, final design stage for finalization and installation. So, and with the objective for the boat to gain Green Plus notation. Yes, so you've invited me to sort of give you a little bit of a background as to how the journey's been. It's certainly been complex. It's been thrilling, and as I say, it started 9 months ago. We installed where I arrived whilst the hybrid system was being installed. We discovered a few things. We realized that we were dealing with quite some high power. There was not a lot of precedent for us to work with. And just before the batteries were installed, we had a couple of moments where the contractors were installing it and our engineer was going about his usual curiosity, and he was asked to back off certain generators because there was live terminals passing 400 to 780 volts of energy, which he wasn't aware of. So there was a silent little threat in the engine room, and that was followed by a few days later of him testing some circuitry, but in the wrong. So in this hybrid system, you have a lot of conversion from AC to DC electricity. And he came up and said, look, I just took a reading, it was 0, but in fact it was live. So we had a few quick about decisions to make. We changed the way we were testing equipment and said that it was all inclusive. But what it resulted in was obviously an acute need to have a big review of where we were at. And what we found is, as this system was amongst the first, if not the first, by this outfit to be installed, there was perhaps a lack of knowledge and maybe even reluctance in terms of being open about the dangers of the system. So we had to reach out, and we started to dig and trying to understand what we needed to do. Our ISM risk assessment procedures gave us a framework, but we need to identify what the risks were. And in this case, many of them are unseen, silent, and still very lethal, unlike your moving machinery or working aloft, and little precedent to go on. So we reached out. We looked at MGN 681. We looked at for lithium batteries in personal watercraft. We looked at MGN 550, written for the Red Ensign Group for battery energy storage, so larger propulsion type lithium-ion battery installations. And at that time, we came across PYA's first webinar, which linked us to some training videos, which were very revealing. And in there, we saw other examples of little, I think the most impactful video that I recall was some young lady going to a laundrette with a little vape and throwing it into a tumble dryer, walking out, and the glass windows of this laundrette being blown out completely. So but the engineer and I looked at each other and thought, well, that's probably 1 amp of energy. We're sitting on 500,000 amps of lithium-ion batteries. So that really was a straightener in terms of how serious and how much we needed to know. And so the story began, and this is why I'm here with you, still an apprentice, and as much as I can share, I need to learn. So hopefully this background is helpful for everyone to understand. So as we moved through this, and we learned more about lithium-ion batteries, we also realized, being a conversion, not purpose-built, we'd pulled out 2 very large Rolls-Royce engines and generators, but we realized that there were 3, broadly speaking, usage groups of batteries, from small devices, laptops and smartphones, toys and tenders, which had some where we found guidance from MGN 681, and then what they call battery energy storage systems. So this is sort of more in our case, it was our propulsion batteries. So this was great background, and we found lots of guidance, and I recommend anyone who's involved or developing ideas like this to reference them. With that, we also realized that there wasn't just one type of lithium-ion battery, but in fact up to 6 different chemistries with different properties, and each of those with a plethora of metrics in terms of what they can do in terms of energy density, power, life performance, charging cycles, cost, and ultimately, of course, safety, all varying in safety. And then we realized that our vessel was in all 3 of these groups. So, of course, like most vessels, we all have our smartphones and our mobile phones. But in that group, curiously, there was less guidance, although we drew quite a bit from the MGNs and class instruction, class specification. But again, going back to the training we've done, we realized that one of the risks of smaller devices, which is not so well defined in guidance notices, is the potential secondary fire and the concept of thermal runaway, and that these, from the first knowledge of, or the first detection of a fault, within minutes, you can have 800 to 1,000 degrees of heat, temperature, flame, and very toxic gases. So how do you handle all of that? Came the question. And the MGNs, so going on to the other groups, where we have personal watercraft, MGN 681 allowed us to give us a background about these things, but and an MGN 550 in terms of the large propulsion batteries gave us a background and a design principles and parameters of what needs to be observed and considered in making these things safe, but did not go so far as what you specifically have to do and how you build these safety systems, but more detail. Whereas curiously, the smaller devices, there was nothing. So we drew what we could from the guidance notes and applied it to small devices. So again, between those three groups, we saw that there were some broad similarities in the way that these safety in these types of usage groups was being applied, and the considerations tend to be containment, ventilation, and in all of these groups, and also monitoring. So we went back to our ISM philosophy in terms of risk assessments, and we started looking at what could be done on a human level or a survey type, or rather a monitoring basis. And so we started thinking about what we could do: crew training, awareness, introducing permits to work, which we're all familiar with, onboarding familiarization for crew, monitoring, and at those stages, monitoring device, the condition of devices, cracks, punctured devices, and the type of chemistry involved. We also created an inventory of batteries, so we knew exactly where and what size of and the chemistry of the batteries throughout the boat. And we started looking at ways of, well, how do we handle these things if they do go off? And on the market, there are various different types of equipment for handling devices that suffer from runaway thermal thermal escapes. So and so we started to plan how we were going to position materials to handle those kinds of events. One of the greatest concerns was the speed from which it goes, the thermal runaway runs into an explosive situation, so speed of response, and also the gases that are emitted. So there we started zoning areas where we would use things like EEBD devices in order to handle these things. We're also including different types of monitoring. This is logbooks, regular checks, CCTV, IR, infrared cameras, and also on the market, you now start to see fireboxes, proprietary fireboxes, which have their own monitoring Wi-Fi links, which have got their own problem and their own cost. And for a boat like us that's retrofit, we can't purpose build for those types of things. So it means potentially having these types of devices on deck, which has got its own sort of implication of how the owner and guests feel about that. And then simpler things, and obviously maintaining and charging these smaller devices to manufacturers' requirements and ensuring that they're all OEM devices and done and charged according to their instructions, requirements, and then also extending our accommodation checks into the way that crew are managing this, because historically, until this awareness, people, I think, all of us were charging computers, plugging them in, and throwing them onto a nicely insulated bed. So things like that we are changing coming into the season. So those were our considerations. With the personal watercraft, we had a couple of other issues. We were thinking about water ingress, damage to the batteries through shock. So, you know, sea bobs, jet skis, water-based watercraft obviously have those demands put on them, and so extra checks are required to monitor the condition of those batteries. And then coming into finally the battery enclosed, so energy storage systems, things are a little more straightforward, because these systems are static, and the principles of enclosing batteries and including firefighting sensors, battery monitoring systems that are monitoring temperature, pressure, gases, smoke, flame, we're able to implement forced air ventilation, can be fabricated into the system, along with water cooling systems and rupture plates. So, which is all possible with you know, although it's a larger installation, of course, it's static, and you have less vibration of the boat, but less shock on the load cell. So, yeah, those were all our sort of considerations. Right now, we are working with a marine consultancy affiliated to our class, and we are now going through a risk assessment process, and the first stage of that is called risk design screening, and this first step is basically the process of brainstorming the risks associated to the installation, and involving all stakeholders, so crew, flag, and class, before moving on to the next step of the actual risk assessment, when the installation takes place, and then the assessment being adapted to the actual problems in installing the theory. So that's our journey, and that's where we are. It's been quite complex, and a lot of different requirements to be met. Along the way, one of the other requirements that came along, of course, was insurance. Our insurers, which caused another issue. We see that different regulators or groups or institutions that have an interest in the safety of the vessel have sometimes slightly different ideas. Our insurers came along and put it to us that every lithium-ion battery-powered device on board, when not in use or being charged, was going to be stored in a firebox, a monitored firebox, which then raised the question of how we were going to do that, when many of our devices, including our communication devices, which are used for safety, UHF devices, torches, and the like, would cause other problems. So some of those, so in those particular cases, we've had to go back to. There's been considerable amount of negotiation. We've been back to the insurers to contest that using class flag guidelines, and they've sort of softened their approach there. But had that not have been done, we would not be insured had one of these devices become a problem. So there's been a lot of negotiation along the way, a lot of different stakeholders and interested parties, regulators, struggling to sort of coordinate their requirements on us. So it's been quite difficult. So I hope, but we start to see the light, and I think it is quite exciting when we get this right. Lithium-ion batteries, it's an evolution, and I think going into the future, we see that that's changing too, and there are much safer chemistries of lithium-ion batteries coming along the way that perhaps won't require the same level of monitoring as these do. But that's where we're at, and it's early days for all of us, and I hope that helps to give a bit of colour to what it's like navigating through these issues. And I'm very interested to hear from anyone else out there what experiences they've had.
Thank you, Ollie, for sharing your story with us. It's definitely very interesting, and for someone like me who's not knowledgeable about the topic, it really gives an understanding of how complicated the matter is. And it seems even more complicated if you need to apply these regulations on a boat that's already there. So you retrofit in a boat for all these regulations to be applicable, and at the same time considering the practicality of these things, like the small devices that you actually need to use on a daily basis, on a regular basis. How do you handle that? But we've received also some stories these days from people saying that they've had some incidents with some of their gadgets on board starting heating up all of a sudden. So Gerard, maybe you can help us find some solutions to all of these problems.
Yes, thanks, Kim, and thanks, Ollie. That story was really interesting. You're at the tip of the spear, so thank you for being so open and sharing with us what's happening. We've had a related question come in from the audience from Darwin Cully, and the question is, what would be the approximate time that the lithium-ion battery could go from normal charging to a thermal runaway temperature? It's less than a second, and the temperature can go from normal operational temperatures to over 800 degrees, like that. It's a cascading set of reactions. No one thing is happening. One reaction boosts the temperature up to 40 degrees, which triggers a new set of reactions within the battery chemistry, which pushes it up to maybe 50 degrees. That then triggers it up to 70 degrees. And beyond 62 degrees is around what they call the point of no return. And then it just becomes exponential until all the fuel is used up. So yeah, so everybody get your questions in, and we'd love to answer them. In the last webinar, I presented about the course and just talked about the subject. We had some incredible feedback from that, and also some questions came in from the audience, and we're going to take this little session just to answer those. People are seeing lots of solutions and products coming to market, and they're trying to understand what is the best thing for the boat, what's the best way to use the owner's money, and being respectful of that, while also getting the outcome you need, which is the protection. So I have a little presentation, and I'll just share my screen. So I'm going to be talking about containment and suppression. I'm going to be talking about products that are on the market. Just in the aid of full transparency, I don't receive any money from any of these manufacturers or suppliers. This is research that I've come across, I've either seen myself, I've talked to the owners of the company, or I've used actually in anger with batteries in thermal runaway. So yeah, so I don't get any reward for this. However, some of my clients do. So but I don't get anything directly. So I'm not really selling. I'm not a salesman. So as I said, we got some incredible feedback from PYA members. Lots of them encountering the same problems as you, Ollie, maybe not as complex with the battery energy storage systems. They share the problems that they face and some of the solutions that they have implemented along the way. But also note, we wrote the course, the Lithium-Ion Safety Awareness course for super yachts, and following on the back of that, a shipping company has approached us to do one for general shipping. So the question is yachting leading the way? Sometimes we can be a little bit isolated and we don't realize how advanced we are. So I think we can take some confidence from that we're having the hard conversations. Lots of industries are, but we're at the pointy end because it's on boats and we've only ourselves to look at for a solution. Okay. So the purpose of this is just to show lithium-ion fire containment solutions and then fire suppression solutions. Ollie made a really good point about secondary fires. We just said that those lithium-ion batteries, when they go into thermal runaway, can go up to 800 degrees in less than a second. In that time, they're burning through all the solvents, the fuels, the chemicals that are igniting it, and they could then the fire could then the heat, the almost white hot jets of hot, superheated gas can die off within maybe 20 seconds as they're used up. But in that time, it's like taking a blowtorch to anything that's nearby, and they will be ignited. So the key is, one, to contain it, to buy yourself some time, and then two, to mount a firefighting suppression response. So we'll look at some solutions on the market. Okay, so the purpose of containment is to restrict a fire in the containment, the compartment of origin, and therefore to allow time to mount an effective firefighting response, while also keeping adjacent spaces free for crew to evacuate or to for them to use in their emergency response. So containment solutions can generally include the battery charging boxes that we're seeing, battery storage boxes and bags, lithium-ion fire blankets, ADR compliant shipping boxes, and then the PyroFlow granules. So I'm just going to go through each of those in turn briefly, just to allow people to know they exist. So MGN 681, battery should be contained inside an enclosure capable of containing a battery fire. So that's as well as the structural fire protection means discussed in SOLAS and therefore MGN 681. So the first box, I really like this. I know the company and I know the CEO, and he's very active on LinkedIn, and he's providing a lot of leadership in the space. It's a German company, and the boxes are called Rackland charging boxes. They're very high tech, high quality, and they aren't cheap. So they're not a solution for everybody. It consists of a non-flammable case with gas capsules to stop any off-gassing, and it neutralizes it. It can extinguish fires inside with its own media, and it's also explosion proof. So it's safe to use in enclosed spaces. There's several different sizes depending on batteries, but the price does start getting up there. The kind of genesis for this was the owner was approached by special forces who saw this need years before us, because they had guys out on operations, and they had UHFs and different devices, and if they became damaged, they could start going off, and probably that wouldn't be a great thing for a special forces operation. So that was the solution, and then he saw that this is wider application. I think they're a great little company and a great box, but again, you have to look at the price. An alternative to that is IAQUA storage boxes, especially for yachts that have limited space, limited storage, and don't have all that luxury of volume to store their boxes. So this is made up of three parts. The outside is a fiberglass gloss, high gloss super yacht style finish. Inside is made of Kevlar against heat and fire. The inner skin, the second layer, is made of another product which is rated to suppress fires, underwriting laboratories in America. It can fit into any interior and almost disappear with the high gloss finish, but it also ensures reliability of the case. So if insurers do go down the route of wanting lithium-ion containing devices stored away when not in use or not being charged or operated, then something like this could be the way. Of course, we would want to be ahead of that requirement and try to divert that requirement, because it is onerous. We have to remember, we're talking about the marginal case of where this goes wrong. All right, this is great technology, but it's looked after, it's cared for, and the crew are aware. Like Ollie said, you do your onboarding you do have some policies in place, and you show the crew, okay, this is kind of special technology, requires a little bit more thinking, and hopefully that will offset anything too onerous. But solutions like these can be easily implemented to try to offset that. Battery storage bag. So again, where space is limited and you can't have that hard solution, there are bags out there. These contain any fire within in the bag. It insulates and also isolates any ejecta. So if a battery does explode because of the high pressure gases, that will be contained inside the battery. It acts as a thermal shield to stop any secondary fires, to at least buy you time to put water down on the fire, and to mount a response. So what are the use cases? Well, I see it as, okay, you've got a policy of, okay, inform the chief officer that you've dropped your phone or your laptop or the toys has been left in the sun. So we're gonna mark it as a suspect until some time has passed. But you might want to put it in a box or a bag or something like that and allow it to sit there for 4 weeks, and maybe somebody checks it every few days. After 4 weeks, all is good. Well, it could go back out. But essentially, these buy extra time so that you're not getting those secondary fires, and to allow the emergency response teams on board to mount a response and start thinking and go through the cycle of the adrenaline and, okay, what do we do here? Then the training kicks in and they know what they have to do. And also, a lot of boats have the luxury of having high fog, but some don't, especially the older boats or the older refits. So they may not have that straight away, putting high fog down. So that's just another containment solution. And then you've got your fire blankets. Lots of these solutions coming to market. Some are using special material, special waves, and some are using special impregnation of the wave with chemicals to suppress that. Some manufacturers are saying these are multi-use and they can be used multiple times. The logic of that doesn't really work through for me. I don't understand. A lithium-ion fire is going to be very toxic and it's going to require severe contamination. And I don't see one of these being washed down, rinsed out, and being put back on the boat in good faith when you can just replace that. So what does it do? So it's same as the normal fire blanket, except these can withstand temperatures over 800 degrees when the battery goes into thermal runaway. So you put it on the blanket, or you put the blanket over it. They were originally conceived for car fires and EV car fires, and all it does is prevent that thermal radiation from setting fire to cars next to it if it's in a car park or something like that, while you get the fire down, or while you get water down onto that. It doesn't put the fire out. Oxygen is contained within the battery, so there's a supply of oxygen usually from the cathode, and so it will continue burning away, but at least you've got something over the top of it containing it. The flip side is it'll be on a deck, so obviously it's not going to protect the underside of the fire, so you'll have to put some boundary cooling on that deck head immediately below the fire to just protect that. And then any explosion, it also contains any ejecta arising from anything popping out. So then you've got transport boxes. What you're looking at is these are simple little wooden boxes, but they're ADR compliant. That's the rules that we use when we have to ship damaged or highly damaged or suspect batteries. You need to get them off the boat because they're suspect. You need to get them off to a recycler. And they are critically damaged batteries. The correct regulations are ADR 21. These are called P911 boxes. I used these over Christmas for a client, a large battery energy storage system, who had 101 6.5 kilowatt hour batteries go in. They had water ejected into them because the fire suppression system on the base, the battery energy storage system, inadvertently released. I just saw an article on LinkedIn saying that up to 25% of battery energy storage systems have some inherent fire suppression fault in them. So we've seen this and we've been at the point end. So we were on 24/7 watches for 2.5 months over Christmas to get these batteries ready for shipping. 7 of them were in thermal runaway, and I'll show you some of the photos of that. But what you're looking at is just simple boxes. They come flat packed, and then you make them up, and then you'll see all that white stuff around. I'll come to that. I'll show you what that product is. That's called PyroFlow. It's just little glass granules, but it allows these boxes to be shipped legally, multimodally, which means they can be shipped on road, and then they can go on board on a lorry, say a flatbed lorry, and they can be then put on the back of a ro-ro ship heading overseas. That's what our operation was, and this is the regulations. That's how I know about it. So I'd like to share it with the association. If you do have damaged batteries, you're liable for the shipping. You have to get them off the boat, but you have to do it the right way so that you're not just transferring your risk inadvertently to somebody in a truck or on a ship. So this is PyroFlow. So it's an expanded glass granulate, and it's used for fire prevention and suppression. It consists of little small spheres of foamed up glass containing internal pores, and the idea is that you put this inside the box, pack this all around it. It's very cheap. We were seeing something like £15 a bag or whatever it was. I can't remember the price. And you just fill up those bags and fill up the boxes, and that's it, good to go. And it works in the event of a fire. The heat causes the glass granules to melt and encapsulates the battery in this molten glass skin, a shell, which then it takes the heat to melt. So it takes that heat out, and then forms an impermeable shell around the fire load and stops it from further propagation out beyond the box. So it's good for when you're trying to ship critically damaged batteries. Good batteries don't have to comply with the same regulation. They'll have their own. Okay, so that was containment solution. So keeping any fire, keeping it in the space of origin or in the container of origin. But MGN 681. So of course, Ollie showed us there's 3 different categories that he sees and I see. You've got your small little incidental batteries, iPhones, iPads, laptops. You've got your toys and tenders, anything above 100 watt hours, anything bigger than a drill, essentially. And then you've got your base. We're just going to be talking about that middle ground, toys and tenders. So we're saying, right, okay, so you've had that fire, you've contained it, but now you've got to go and mount a response. So what are the solutions out there? Well, there's lots of different solutions that we look at, and I've had some experience now of applying them, using them at Anger and batteries and thermal runaway. So I just want to show you 2 of those. You'll probably be very familiar with this. This is Litex from Fire Chief. This is AVD, aqueous vermiculite dispersion. It's another mineral. So this is vermiculite, is you can get from horticultural shops. This is what you would put in your ground. It's just a mineral. They dig it up. So essentially, lithium is a mineral. This is a mineral. So you're using a mineral to fight a mineral fire. It's naturally occurring. It has water molecules trapped inside its own structure, and that helps cool any fires that it's in touch with. So it's really good for lithium-ion. And as it dries, it cools, and then it also encapsulates the batteries, provides a thermal and a little bit of an oxygen barrier. So that's me using it. What you're seeing, what you're looking at is a large 6.5 kilowatt hour battery. We were babysitting these all over Christmas. We found 7 of them using infrared. We found 7 of them were approaching thermal runaway, point of no return. We saw a difference between ambient and what the battery was reading of up to 50 degrees, and that's when the whole operation changed, and we went into kind of containment and emergency response mode. I don't have the photo here, but you see the black plastic that had melted away on some of them. So while the lithium-ion, we've seen the videos and things like that, we're reading the articles and we're reading the research papers, it was all very hypothetical until I actually had to go and deal with it, and you realize this is real. So this is every single lithium-ion battery is susceptible to this if it's not taken care of. And these are big industrial batteries for a battery energy storage system, like a UPS for the power grid. It just dumps in 50 megawatt, huge 50 megawatts of power into the grid if the wind power falls off. So that's AVD product you'll see called Lithium. So a lot of boats will probably have that. So this is fire block gel. So this is second generation firefighting, fire suppression for lithium-ion fires. It's a polymer-based product. I've signed an NDA, so we can't really say how it works, and I probably couldn't explain it because it's highly technical, and I'm not a chemist, so I'd probably get the names wrong, and I'd probably get the mechanism by which it works wrong. But I saw a video from a manufacturer where they dipped their hand into, obviously, I couldn't show it. I don't think it's right to show it. They dipped their hand into the gel, and then they took a blowtorch to their hand, and they just showed the thermal capabilities of it. We were like, yeah, we can't show that in a safety association. It's a great product. It's a great thing to see, but no, nobody would appreciate seeing that. That's like testing a bulletproof vest by shooting guns at yourself. But we've used this, so it's a green gel. It sticks to the surface and protects it from fire and from thermal radiation. We used this in anger. We went from AVD. What we saw was the temperature profile with AVD. Once it dried up, the temperature started creeping up again. So it expanded our resource, our firefighting medium. And then once it dried, it did its job. It's not there for the long term. It's not meant to be for that. It's meant to buy you some time. We saw the temperature infrared, which signature would start creeping up again. So we went to this product, and we actually got IBCs full of it, as well as extinguishers. Now it's slightly more expensive than AVD, but for my own use and my own experience, it did the job. It gave us the comfort that we needed. So it provides a sticky gel layer. So onto the fire, onto the fire source, and it prevents the fire from reigniting. Essentially, it just whatever's happening chemically, it's an endothermic reaction, so it's just sucking the heat right out of it, out of that flame, out of the thermal runaway and the batteries. So it was great to watch that. We would watch the temperature creep up, and then when it hit a certain point, we'd dose it with this, and that would be it gone, and it would stay like that for a week. We noticed that whenever it had done its job, the green turned to slightly blue, to showing at the areas that it had done its job, but there was still plenty of product left over to do that. But we just kept dosing it just to be really safe. So that's called fire block gel. It's a derivative of a product that's used in forest fires and agricultural fires. There was a huge biowaste heap fire, maybe 20 meters high. They tried dousing it with water, and I think that was in South Africa. They tried to douse it with water, and it didn't happen, and didn't really knock it down at all. So they put this on it, and the video shows the fire just going out within 10 minutes. So it's really powerful stuff. So really highly recommended for me from using it. Okay, so that shows my little survey of what's out there. There's much more out there, but hopefully that'll give you a way of thinking about the solutions, categorizing it in your own minds, and then when you go out there, there's lots of products coming to the market. I can't really speak to the effectiveness of any of them, other than the ones I've used and the companies that I know. But you can reach out to On-Teep Ship Supply for these products. Of course, I work with Seascope France, and if you'd like to talk about them more, there's the contact details, and you can contact me on LinkedIn if you need to know anything. Thank you very much.
Thank you, Gerard. So just a reminder for everyone who's watching, if you have any questions, feel free to feed them in the chat. We got a few of them that we can answer perhaps in a bit. So thank you, Gerard, for the very extensive explanation on these various products. There are a lot of them out there, as you said. And now, Ed, can you tell us a bit about how does lithium-ion safety relate to the ISM code?
Yeah, thank you very much. Well, first, thank you for everybody who's interested in this topic and is present during these presentations. That is already a highlight of the issue which we face in the yachting industry, that the people who are now in the seminar are probably interested in safety and want to do good, and they want to move the goalpost and do already proactively some research to be informed. My biggest headache is the ones who are not aware and are not in this seminar, and the ones we see hopefully every year to put some reminders forward as a regulator during a flag state survey. That is where the pain mostly lies. So everybody in this audience already has expressed their interest to do good. So this is what we face. Then for the people who are interested, I want to unwrap a little bit the story of Olof, what was very interesting. I quite like the case because it speaks to you. And Olof had a lot of issues to tackle. First, it was an existing ship, which I assume is classed and has a flag state. If you have an existing vessel, it's already what kind of regulations do you pick? And if the ship is subject to a major conversion, then you kind of refer to the latest rules out there. I don't know the case of Olof, but I would assume that this was for class and flag a major conversion. Hence, you can refer to up-to-date legislation. If you have an existing ship, and most of the yachts which are out there are existing, and you carry, you just carry a few lithium-ion batteries on board in the form of a toy, the seabob, the surfboard, the ones we discussed, a scooter, then you kind of create a problem on a vessel which was not designed for that, but now gets stuff on board which it's not really protected for. Within Cayman, we kind of determined after a few fire incidents that this was an issue. And from 3 years ago, the people in the audience who work for management companies will recall that we standard issued a survey remark where we invited the ship and hopefully the management company, but not all small yachts have management companies, but we invited the yacht to do a risk assessment on their own situation. And this was not straight away connected with the ISM code, because many yachts under 500 gross tons do not even comply with the ISM code. They have a so-called mini ISM that doesn't exclude you from doing risk assessments, but it's a lighter version. And some of the yachts are fully pleasure, and not only coding is not compliant, is not mandatory, class is not even mandatory. So you only have to comply with marine environmental regulations, the MARPOL, which is the lowest bar you can set. We in Cayman are quite fortunate that I think 90% of our fleet is either compliant because they have to, because they're commercial, or do it on a voluntary basis with some exclusions. And the 10% left is difficult, because every rule in the world for shipping was written for the merchant navy, and pleasure registered bulk carriers or tankers do not exist, but pleasure registered yachts do. So you can pick and choose if you apply the legislation. We highly recommend, but we don't fully enforce if the owner doesn't want to. So there is already a tension field there, that for pollution you're regulated, but for safety not in entirety. That's I probably the people who saw me speaking elsewhere, I kind of often make the surveyor's joke: you may kill, but you may not pollute. But if you set fire to the ship, you, in a quite complicated way, pollute the environment anyway. So you should do everything to prevent the fire from happening anyway. So what we can recommend, apart from what is in the law, so from the July this year, in the large commercial yacht code, now called the Red Ensign Code, there is the MGN 681 will be mandatory for key laying date or contract signing dates after July 2024. So it's not a discussion anymore, that will be a rule. For existing vessels, for propulsion batteries, which Olof mentioned as well, there was already a common Annex A in the Red Ensign Code, and there are various class societies with their own rules. And without arguing how good our code is or how good the class rules are, but that was already regulated. Propulsion batteries. For items we have now on board of yachts which are not subject to these new rules, I can only say take away the principles of 681. You might not be able to do it all, but you can take on board a lot of items from it to make it from zero to hero. You might not do it all, but you can make it with low-hanging fruit to be picked. You can make big steps. And then items which Gerard showed me, I see them in my survey, a variety of like the fire blankets, the fire extinguishers, taking on board these principles on existing vessels, and the risk assessment should be ship specific. I quite often encounter new equipment on board, say the lithium-ion battery toys, and they then stored next to the petrol canisters. That might not be the best place to do that. So looking into how your ship is designed, taking into the experience of the crew, taking in the experience of surveyors, people from management companies who see more yachts, experienced captains, seminars like this, have a critical look towards your own situation. And then you can call it all fancy words, but in a way you're doing a risk assessment. And the risk assessment, you asked me for the link of the ISM code. Now, I made a few notes for the ISM code. In the ISM code, there is nothing prescriptive. We're not going to tell you need to carry 2 extinguishers or whatever. No, you need, by means of the ISM code, to risk assess your own situation. So proactively. So you don't look of the incident, it happened, it's fire, what do we do? No, we are going to look into what do we have on board? And not only lithium-ion batteries, but what do we have on board? Petrol toys, what do we do with the ship? We're going to navigate close to the coast. So that every aspect of that, you know what you're going to do, and you know that there are certain risks attached to it. So the principle of the risk assessment is super important to try to prevent something happening in future, and not after it happens say, oh, we should have carried a few more extinguishers. So look forward. That's in plain word what I would like to say. Then there's of course a basic principle of responsibility. If you are ISM coded, it's not only the ship, also the company who carries the document of compliance in the yachting world, the management company, they are also responsible for what is done on board of the yacht. So there's a big role there for management companies to guide, assist, stimulate, train the people on board who might, in their own bubble, do the best for the owner, but are not fully aware of what happens in an entire fleet. So learn from each other. I do surveys every day, like I said in my intro. I am learning every day. After 3 decades, I'm learning every day. That might be because I'm a slow learner, but it's also that I quite see new situations. Then we have other things relating to the ISM code. You have standard operational procedures from the ISM code. So if you charge the lithium-ion battery in this case, there are steps to be done, and on your own situation, you can tailor these standard operational procedures to the ship. So don't roll out one operational procedure for the whole fleet. No, check what type of battery is there, what charger is it, or is it the stuff you can use, what position is it monitored, are the people trained to do it, all aspects of that. Then I mentioned already training. The ISM code will actually state you should have sufficient resources on board for safe operation on board. So the people who are involved in doing the job on board need to be trained. Quite often the knee-jerk reaction is, oh, what a bloody stupid crew, the vessel burned down. But were they trained? Was the equipment put on board last minute because the charterer wanted a surfboard on board? Can you really say that was all just because they were stupid? I don't think so. I think you should be very keen and eager to provide sufficient training for people who do a specific job. And if you deal with a certain new risk, there might be certain new training attached. So raising awareness by means of these seminars, by means of changing legislation, but also stimulating people to be trained. And not only for lithium-ion batteries, for all kinds of purposes. Training can prevent a lot. And then there is the, briefly mentioned, the insurance companies. Due to the fact that not all yachts are subject to the code because they're pleasure or they are not voluntarily compliant, and insurance companies sat together because they also acknowledge the risk. I sent the standard insurance policy clause to Kim to share with the audience. I had contact with insurance companies, and one of the insurance guys was an ex-MCA surveyor, Adam Jackson. He shared with me this clause, which the insurance company together will roll out over your vessel. And it might be very good of everybody who is in this audience to check if their vessels do meet the insurance requirements, because you could have the nasty situation where you indeed meet class and flag state requirements, either because you do, or either because there are no requirements because you're a pleasure yacht and you're still not meeting the insurance requirements. And under ISM, you could actually say, you can do it the other way around, because ISM requires you to all applicable rules and regulations, inclusive of what an insurance company demands. So you can't really hide behind, we didn't know that. But I want to highlight that the insurance companies are taking specific notice to this, and I issued a document, which is good to read through. I think from my side, that is what I wanted to share with you. And again, I appreciate very much that you are in this audience, because that sets you out from the rest already. Thank you very much.
Thank you, Ed, for sharing all this valuable information. So the document that Ed mentioned, the insurance clause is available in the chat for download, and we will also share it by email afterwards. Now, I'm conscious of the time, so I'll ask our panelists if they have anything else they would like to add, or if our guests have any last-minute questions that they would like us to address, either via the chat or raising the hand.
So I just see we've had some more interesting questions come in through the webinar chat. We've had one from Alessio Alemo. I hope I got your name right, Alessio. Was one extinguisher enough to take down a 5 kilowatt battery fire? So if that's the project that I was speaking about, that I was on over Christmas, no, we didn't actually. We prevented them from going into fire. So it was about sucking the heat out of it to keep it away from that point of no return, 62 degrees. So I think we used 9 liters. We applied it really liberally, but we also had an intermediate bulk container, so a ton of it sitting right next to us. So a ton of green gel ready to use if we wanted it. And then have most portable lithium-ion extinguishers now received Marine Equipment Directive. So ABD is MED. So Marine Equipment Directive is just approval for use of equipment on yachts. The other panelists would be able to come in and probably say more. The fire block gel that I spoke about is in the process of obtaining it, and the British equivalent, since which is a new system. So that will come. That fire block gel also is incorporated in the system for battery energy storage systems, which can immediately supply into racks of batteries for installations. And what about Lithex? So that is Marine Equipment Directive. So that does have the wheel mark. And then just to recap on what Edward says about ISM, I did the risk management plan for this operation for my client, for this big operation. It took us 2.5 months, and all I did was apply the ISM code. So don't think the ISM code is something that's special to ships, or it just has this one use case. It's a fantastic tool to help you to think, because you approach this and there's so many different aspects to it where you have to start chunking it down into different subtopics. And I just use the elements of the ISM code to do that. Risk assessment, hazards, risk assessment, controls, and then tasks, and just formalize it as per the ISM code.
Do we expect product options to increase in the near future?
Yes, absolutely. I follow an academic from Newcastle University, and he's just informed us that he's testing, doing product tests. So his job is pretty cool. He sets fire to these batteries, so he induces thermal runaway in a safe environment, and then applies products to test them to see whether the manufacturer's claims. So the manufacturers of these products pay him to do that research for them. There's lots of testing organizations. I know another one up here. So yes, they're coming to market. Yes, there's more coming our way. Some of the products he said I wasn't aware of, and they sounded quite exotic and cool. So I'm looking forward to seeing what those are.
Perfect. Excellent. It's nearly 1 hour. Unless we have any last minute comments or questions, I think we can close this webinar. If any of our guests have further questions that come up later, don't hesitate to contact us. You can contact us at info@pya.org or Antibship for information on the products. So thank you again to all our guests and our panelists for making this possible and giving us their time. Thank you so much and have a great day.
Thank you.
Thanks, Phil.
Thank you. Thank you, Ken.
All right. Cheers now. Bye-bye.